In a previous exercise, you may recall we chose the image size command, we made sure resample image was turned on, and we set the resolution value to 600 pixels per inch. So in other words, we're upsampling. Now let's see what the repercussions of that upsampling are and how we control the way Photoshop generates new pixels. Now, in order to see how many new pixels are getting generated, I'm going to go ahead and switch the width value here from pixels to percent. And we will now see that I am increasing the width of the image by 600%. I'm also increasing the height to 600% of its former size. So 600 times 600 gives us an overall increase of 3,600%. So in other words, we're making the image 36 times its former size, which means we're going to have to take 1 pixel in the image and make 36 6 by 6 pixels out of it. And how in the world are we going to do that? Well, before I answer that question, let me show you a little tip. Let's say that you want to change one value independently of another. For example, I want to change the width value as a percent, but I want to see the height value in pixels. I would press the Shift key and choose pixels, and that way these two values change independently of each other. Just FYI. Anyway, to answer the other question, how is Photoshop going to pull this off? We drop down here to resample image. Now, resample image is on. It means that we're going to change the number of pixels inside of this image. Specifically, we're going to upsample the image, add pixels to it. You want to make sure that not only is it on, but constraint proportions is turned on. That way you're changing the height and width by the same amount. And then scale styles, that affects layer effects, things like drop shadows and glows and a bunch of other stuff, whether they get scaled along with the rest of the image. In our case, we're dealing with a flat image, so it doesn't matter. When in doubt, when you turn on resample image, have all 3 checkboxes turned on. When you turn off resample image, they're dimmed, so you don't have to worry about them. But when resample image is on, all 3 should be on. Then we drop down to the interpolation option, which determines how Photoshop calculates the new pixels. Now, this gets technical, but it's worth knowing. It starts off with nearest neighbor. And nearest neighbor doesn't do any averaging. All it does is it takes 1 pixel, turns it into 36, moves to the next pixel, turns it into 36. So you see the exact same kind of mosaic effect that you see when you magnify the image with the zoom tool. So when I'm shooting a screen for one of my books, I'll blow it up to 200% or 300%, some multiple of 100. And I'll use nearest neighbor to do that so I don't introduce any smoothing or any softening into that screen element. And then I'll take a high resolution image element, combine it with the screen element, and I'll have a great looking figure. We've got bilinear. I don't ever use this option. It's a poor man's bicubic, which is your best when in doubt setting. And so it ostensibly works a little faster. You shave off microseconds with this option, and it definitely does a worse job. Bicubic, the best of them all, goes ahead and considers the most neighboring pixels when trying to figure out the color of a new pixel. And it's not perfect for upsampling, but it's as good as it gets, quite frankly. Now notice that it says best for smooth gradients. What it's saying is it's going to do the best job of keeping the transitional colors that are already at work inside of an image. It has nothing to do, however, with gradients per se. Now, the next 2 options, smoother and sharper, also have misleading parentheticals, by the way. And they basically add a little bit of averaging or sharpening to the final result, and just the tiniest amount, I have to say. Now, bicubic smoother, if it's useful for anything, and I rarely use it, but it has nothing to do with enlargement. It has everything to do with defeating noise. So if you have noise in an image, which are random flecks of neighboring colors, essentially, where things ought to be nice and smooth, so you'll see noise inside of clouds and sky, where you'd rather see smooth color all the way around. If you have lots of noise and you need to resample an image, whether downsampling or upsampling, then you might want to choose this option. Bicubic sharper has a much more clear use, in my opinion. It's good for low noise images, where the image is nice and smooth in the first place. But it's really great for creating web graphics. So if you're reducing an image for web output, then it ends up creating a nice, sharp screen image. If you're reducing the size of an image for print, it's of no use whatsoever, because that sharpness is not going to be visible at a high resolution. So in our case, I'm going to stick with the default option, bicubic, best for smooth gradients, though it's not. And then, in the very next exercise, I'm going to click OK to apply these settings.